A 240/120 volts 200 amps split neutral load center with a grounding electrode conductor connected to the equipment ground bus and no main bonding jumper presents several potential problems beyond just code violations. Firstly, National Electrical Code Section 250.24. A violation: the grounding electrode conductor must be connected to the grounding electrode system at the service entrance and at all subpanels. Secondly, National Electrical Code Section 250.28. For violation, a main bonding jumper must be installed in the service equipment to connect the grounding electrode conductor to the equipment grounding conductor. Without a proper grounding system, there is an increased risk of electrical shock if a fault occurs. The grounding electrode conductor provides a low resistance path for fault currents to flow to the earth, protecting people from contact with energized components. A poor grounding system can cause voltage fluctuations, which can damage sensitive electronic equipment and appliances. Improper grounding can lead to corrosion of metal components and electrical arcing, which can create fire hazards. Faulty grounding can also damage electrical equipment, shortening its lifespan and increasing the likelihood of future problems. In some cases, a poorly grounded system can cause circuit breakers to trip prematurely, disrupting electrical service to critical appliances and systems. Grounding problems can also create interference with other electrical circuits, causing them to malfunction or become noisy. A proper grounding system is essential for effective lightning protection. Without a proper grounding electrode conductor, lightning surges may not be properly dissipated, increasing the risk of damage to equipment and structures. Let's delve deeper into each of these potential problems, starting with the increased risk of electrical shock. The grounding system's primary function is to provide a low impedance path for fault currents to return to the source. This low impedance path ensures that when a fault occurs, such as a live wire coming into contact with a metal enclosure, a large current will flow. This large current will quickly trip the circuit breaker or blow the fuse protecting that circuit, thereby disconnecting the power and preventing a dangerous shock. Without a properly connected grounding electrode conductor and a main bonding jumper, the fault current path becomes high impedance. This means that a smaller current will flow, which may not be sufficient to trip the circuit breaker or blow the fuse. As a result, the metal enclosure can remain energized at a dangerous voltage, posing a significant shock hazard to anyone who comes into contact with it. Voltage fluctuations are another potential problem stemming from an inadequate grounding system. A stable and reliable grounding system provides a reference point for the voltage in the electrical system. This reference point helps to maintain a consistent voltage level and prevents voltage fluctuations. When the grounding system is compromised, the voltage can become unstable and fluctuate. These voltage fluctuations can damage sensitive electronic equipment, such as computers, televisions, and audio equipment. These devices are designed to operate within a specific voltage range and can be damaged if the voltage deviates too far from that range. In addition to damaging electronic equipment, voltage fluctuations can also affect the performance of appliances, such as refrigerators, washing machines, and dryers. These appliances may not operate efficiently or may even fail prematurely if subjected to voltage fluctuations. Corrosion and arcing are further concerns associated with improper grounding. When the grounding system is not properly installed or maintained, stray currents can flow through unintended paths. These stray currents can cause corrosion of metal components, such as pipes, conduits, and enclosures. Corrosion weakens the metal components and could eventually lead to failure. Electrical arcing is another potential consequence of improper grounding. Arcing occurs when electricity jumps across a gap in the electrical circuit. This can happen when connections are loose or corroded, or when the insulation on wires is damaged. Electrical arcing generates heat, which can ignite flammable materials and cause a fire. Equipment damage is a broad category that encompasses various problems that can arise from faulty grounding. As mentioned earlier, voltage fluctuations can damage sensitive electronic equipment and appliances. In addition to voltage fluctuations, improper grounding can also lead to other types of equipment damage. For example, if the grounding system is not properly bonded, it can create a difference in potential between different parts of the electrical system. This difference in potential can cause current to flow through the equipment, which can damage the internal components. Furthermore, a poorly grounded system can make electrical equipment more susceptible to damage from power surges and lightning strikes. Circuit breaker tripping is another symptom of a poorly grounded system. When a fault occurs in a properly grounded system, the fault current will quickly trip the circuit breaker protecting the circuit. However, in a poorly grounded system, the fault current may not be large enough to trip the circuit breaker. This can result in the circuit breaker tripping intermittently or not tripping at all. Intermittent tripping of circuit breakers can be a nuisance, as it can disrupt electrical service to critical appliances and systems. If the circuit breaker does not trip at all, it can create a dangerous situation, as the fault current can continue to flow, potentially causing a fire or an electrical shock. Grounding problems can also create interference with other electrical circuits. This interference can manifest as noise in audio equipment, flickering lights, or erratic behavior of electronic devices. The interference is caused by the fact that the grounding system acts as a return path for electrical current. When the grounding system is not properly installed or maintained, the return currents can flow through unintended paths, creating interference in other circuits. Finally, a proper grounding system is essential for effective lightning protection. Lightning strikes can generate enormous surges of electricity that can damage or destroy electrical equipment and structures. A properly installed grounding system provides a path for these surges to safely dissipate into the earth, minimizing the risk of damage. Without a proper grounding electrode conductor, lightning surges may not be properly dissipated, increasing the risk of damage to equipment and structures. In summary, the absence of a main bonding jumper and the improper connection of the grounding electrode conductor in the described electrical panel create a multitude of safety hazards and potential equipment problems. Addressing these issues by bringing the system into compliance with the National Electrical Code is crucial for ensuring the safety of people and the reliability of electrical equipment. The grounding system needs to be inspected and upgraded, adding the missing bonding jumper and verifying correct grounding electrode conductor connections.